This is the solution video for problem set 6, problem 4. And in this problem we are just basically solving two timing diagrams. My printer didn't do a great job with this, apparently. So we'll add those back in. And I'm not sure what happened there. So first thing we were just want to basically make sure is that we only change on the positive edges. And apparently my printer had a bad spot in the cartridge or something there. And so we really only need to worry about what happens at these clock edges. So we know we start off with the initial state is 0 for both Q1 and Q2. So Q1 is 0 up until the first clock edge, as is Q2. So the next thing we need to figure out is how these things are affected. So essentially, this is a function of in and Q2 before the previous clock edge. So Q1 is just Q2 NANDed with in, so that's actually going to be 1 NANDed with 0, so that's going to be 1. So Q1 is going to change to 1 here. And then this is the Q2 is going to change based on Q1 before the clock edge and the output of this NAND before the clock edge. Well, it turns out that these are the same, so pretty much I'm just going to be XORing this with this, because this is the output of the NAND before the clock edge, interestingly enough. So 1 XOR 0 is 1. So this is going to change to a 1. And we've got Q2. Now let's do Q1 again. So Q2 is 1, in is 1, so NAND is going to be 0, so this is going to drop back down. And then the XOR is basically going to be the XOR of this and this. So this is going to drop, this is going to stay at 1. Oops. So that's good. And now Q2 is 1, in is 0, so this Q1 is going to stay 0 to the next clock edge. And because the NAND was 0 and Q1 was 0 before the clock edge, Q2 is going to drop down. And then this next part, we have Q2 is 0, in is still 1, so that's going to change Q1 back up to 1. So essentially we're back at the beginning, really, with that one. That's the same. So because kind of by similar reasoning earlier, this is going to go back up to a 1. And now in is 0, so no matter what, this is going to output a 1, so this is going to output a 1 here. And then Q1 before the clock edge was 1, NAND before the clock edge was 1, so that XOR is 0. That's part 1. And so now for part 2, you needed to write a solution strategy, so I'll kind of describe how I think I'm going to approach this. So I need to read the problem first. The sequential circuit below has a positive edge trigger T flip-flop, okay, that's important, and a combinational circuit G whose output is the function G of XZ. Complete the timing diagram by showing the waveform for G, assuming that there is negligible delay in G. Specify G with the truth table. Okay. So the first thing I know, since it's a T flip-flop, I can tell what the T input is before the clock edge which is G, by whether or not this toggles. So if Z toggles, I know that G prior to that clock that positive clock edge had to be 1. So here we got a toggle, here we've got a toggle. This is going to make this a 1. The other thing I know is that if it doesn't toggle, that G is going to be 0 right before the clock edge. So it's going to be 0 here and here. So I'm going to first calculate my clock edges, and then depending on what information I can gather from that, I'm going to try to fill out the remainder of my truth table based on these clock edges. And after I fill out my clock edges, I'm going to go back and fill in the rest of my timing diagram just to finish everything off. So that's kind of the order I'm going to do things in. And so let's look at the clock edges. So Z does not toggle, so that means G had to be 0, or just before the clock edge. Here, G toggles, or Z toggles, so we know G had to be 1 right before the clock edge. I don't have a toggle here, so that means G was 0 slightly before the clock edge. And here I have a toggle, so that means G was 1 shortly before the clock edge. So hopefully that's enough information to complete my truth table. I have 4 clock edges and I have 4 combinations of inputs, so this should be enough. X is 1, Z is 0, I get 0. So X is 1, G is 0, I get 0. X is 0, 0 gets me 1. 0, 1 gets me 0. And 1, 1 gets me 1. So I've got a NAND, an XOR. And so here I've got Z is 0, X is 0, Z is 0, which should be a 1. And here I've got X is 1, Z is 0, so that's going to be a 0. So they're the same here. They're different here. They're still different here. They're the same here. And they're different here. So that completes that second timing diagram for part 2 and this video.